Okay, here we are with another episode of Money Button Documentation, where we're covering not just Money Button, but also all of the sort of technology that you need to understand to be able to build applications on Bitcoin SV. And we're going to talk about base 58, which is a way of encoding data that is used inside Bitcoin addresses. We won't really talk about Bitcoin addresses quite yet, but we'll talk about how they're encoded because it's kind of its own special thing. So let me just sort of dive right in. So give me a second here and let me share my screen. And probably the best thing to do is actually let's quickly look at the documentation first, and then I'll share my my terminal. So, okay, do you see my documentation there?
Yes, perfectly.
Okay. Yeah, we did.
Okay, so base 58. So what this is basically a way of encoding data in what is base 58, and I'll explain some of this in a second here, but we'll just glance through the documentation first. So it consists of 58 characters, and we have two classes. One is base 58, and the other one's base 58 check. So they're used in particular for encoding Bitcoin addresses, but a few other things like you can encode private keys this way, and you can encode anything else. And our documentation just shows you how to use this stuff. So let me switch over to my terminal. I'll explain a bit more background about what this is and how to use this. So in order to understand base 58, so first of all, I figure it's helpful. We kind of covered this very quickly when we looked at big numbers, but we should understand what even is a base first. So in JavaScript, we have basic numbers. So we have things like 5, 6, etc. This is all written in base 10. So I could do a big number like 15,789 or whatever. What we can do is we can easily convert from base 10 to other bases in JavaScript. So if I want to convert it to binary, I just say toString, and it converts it to binary. If I want to convert it to hexadecimal, I can convert to hex really easily. So this is base 2. This is base 16. I think it might even do base 64. Let's see what happens. No, it doesn't do base 64 built in. But what I can do is, if I want to do base 64, what I can do instead is I do something like this. So first of all, let me generate, what I'm going to do is get a long random string here, like often. Get random buffer. And let me call it something, var buff equals that. Oops. Var BSV equals require BSV. Okay. Now what I have here is just generated a long random buffer, like normal. Now what you can do with this is hex is base 16. So we can simply output the buffer with base 16. We can also output the buffer with base 64, which I think I just typed in base 64. Yes. Okay, so Node has built-in support for base 64. Now we also know, as we saw the other day, we can do like big numbers. So I can, if I want to write down this buffer as a normal base 10 number, I can use our big number library. From we'll do from buffer buff, and I can say bn.toString, which defaults to base 10. So this is that same number written in base 10, and this is what it looks like in base 64. So one of the, like, why does this matter and why do you care about this? Well, sometimes if you're communicating a number, like in a URL or in an email or whatever, and it's a long number like this, you want to encode it in a short way, but you can't necessarily just dump binary data. So base 64 is something that's often used for that. The only problem with base 64 is that you have these weird characters like a slash and an equal sign that show up inside base 64. And so if you're putting these inside of a URL, well, slashes actually have special meaning inside of a URL. And equal sign also has special meaning inside of a URL. So these actually isn't really a very good encoding inside of a URL. And there are a lot of other cases when it's not a very good encoding either. So what we have with Bitcoin is we have something called base 58. So I can do this here. What I'll do is I'll make a new base 58 object, bsv.crypto.base. I'm sorry, it got encoding dot base 58 dot from buffer buff. And then I can do this. I say, whoops, I did that wrongly. I called it buff, but that's okay. Buff dot to string, and now I can output what it is in base 58. So base 58 is all these characters, 58 of them instead of 64. So it's an unusual number because it's not a power of 2. But it doesn't have slashes and it doesn't have equal signs. So some of the numbers it does, or some of the characters it doesn't have, are sort of slashes, equal signs. It also doesn't have a capital I or a lowercase l because those are ambiguous letters. So, and it doesn't have things like capital O or 0, if I remember correctly. It might have one of those, but it doesn't have both of them, so that it's not ambiguous. So it's useful if you're writing it down, you never have an ambiguous number. In fact, I think it doesn't even have a 0, if I remember correctly. I think it has, yeah, it actually doesn't have 0 or O. So it doesn't have either of those characters. So all the ambiguous ones are left out so that you never have that. So it's just a way of encoding data in this special format where you can do things like, if you were to write it down by hand, which hopefully no one ever has to do, but if you do, which in theory was the case early on in Bitcoin, where you might be writing down a Bitcoin address by hand, you are less likely to make a mistake because you don't have any of the ambiguous characters there, and you don't have any weird symbols, and it has cool properties like you can put it inside of a URL, and because it's basically just numbers and letters, it always works. The next thing we'll do is we'll talk about base 58 check, but before I move on to that, any comments or questions about what is base 58 first?
No, for me, it's clear. I just wonder if it's used in any other place aside the addresses in Bitcoin, or you know any other place where it's used?
Addresses and private keys, as well as BIP32. So when you see an extended private key or an extended public key, those are also written in base 58. To my knowledge, those are the only cases I can think of anyway that use base 58. So it's actually not unique to Bitcoin. There is, I believe Flickr was actually the first service to use base 58, if I remember correctly, way back in like, I don't know, 2007 or something like that. And Bitcoin used it because it was appropriate for Bitcoin addresses, but it's not very widely used outside of Bitcoin. Bitcoin is sort of the biggest application of base 58. But okay, so the next thing is, so there's another one called base 58 check encoding that we should be aware of. So that one is, so unfortunately I broke my buffer here, but let me get my buffer back again. I'm going to make my buffer again. Var buff equals buffer X again. Okay, now I've got my buffer back. Now there's another encoding called base 58 check. So the encoding dot base 58 check dot from buffer buff dot to string. I'll show base 58 check and base 58. Now the difference between these two are that base 58 check encoding also includes a hash function at the start. So when you take your data, what it does is it adds to it the hash of itself at the front, which means that basically if you were to mistype one of these characters, it would fail. So for instance, if I take, I'll give an example where I start with, if I were to take the base 58 one and I now want to input it, so I say something like bsv.encoding.base58.fromString, and I input this thing. What I'll do is how can I do this here? I'll do .toBuffer, I guess, .toString hex. Now we'll look at like the very start of it. Let's say I mistype something and I type in like an 8 instead of a 9. I get a different value at the front because obviously I mistyped it. But that's a property of base 58. If I do base 58 check encoding, this one right here, I'll do the same thing here, but let me print it out two different ways. So if I simply input my base 58 check encoded symbol, I get that back again. And if I were to change a character like V into T or something like that, it actually breaks because the checksum has been broken. So using base 58 check, which is what addresses actually use, it has all the properties of base 58 plus a checksum, so that if you, even after all that, you still mistype a character, it's going to be invalid. And so the reason why that matters is basically if somebody gives you an address, and God forbid if you ever have to do this, hopefully not, but if you have to write it down by hand and you type it in wrongly, it will probably not work. It is very unlikely that you could accidentally type it wrong. It will fail, which is much better than accidentally sending money to an address that can never be recovered. So it's primarily for addresses, and it's primarily for that reason that it's all but impossible to accidentally send money to an address that's incorrect. Okay, so let's look at the source code just so we can scan through this and see how this works for people that are super curious about the low-level stuff here.
So besides checking addresses, there's any other application for check 58?
Only private keys, addresses, extended private keys, extended public keys. And outside of Bitcoin, I mean, you could imagine lots of other use cases. But hopefully what we'll do is, like, basically anytime that you have to worry about this, it seems like we've already made a mistake, because users shouldn't have to write this stuff down. So hopefully as we get money button all over the internet and stuff, and people are swiping money button instead of copying and pasting addresses, it won't even matter anymore. So it actually only really matters to like an application developer, actually, that they are unlikely to copy an address wrongly. But hopefully the user never has to worry about this.
It's cool to know that this base 58 check exists, because you could use it for other stuff. Like, let's suppose that you have vouchers for users on your product, like discounts or something like that, that could be shorter than an address to make it easy to write like 5 or 6 letters. And you can do it in this way that if the user types wrong something, you can recognize that it was missed. So it's really cool to know that it exists.
Yep. Agreed. We can certainly, anytime that the user has to write something down, this is a very good option to prevent errors. Okay, let's see. Okay, and actually, let me share a different screen here. I've got my other terminal open, which actually has the source code already open. I think this is the correct one. I don't know which screen you guys are seeing. It's like it's showing me 2 different code windows here.
We are seeing the one that says, I believe it's the one that you want, base58.js.
Okay. All right. Okay, so let's just quickly look at it. So inside the source code, it shows you the alphabet. Now we're actually using a library like usual inside of BSV. We're actually using many different libraries that are actually all glued together. So there's actually a library that's a very good library called BS58, which is very fast. People have optimized this over time. It used to use a big number library under the hood, but now it's just a sort of a pure implementation of base 58, and it's very fast. But we can see the sort of the alphabet, which is all the characters. So instead of like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which would be base 10, it's all of these things. So it's 58 characters, and you can find the length of that, and that is 58 characters long. And basically, you have this base 58 object, and there are 2 different ways to use it. You can either encode a buffer and then decode a string, or you can use the from buffer and 2 string methods. So that's basically it. And so we have our documentation covers a sort of to and from buffers and to and from strings. And then you can also look at the one that includes the checksum. So if you were to try to say do base 58 check, you can find where it does things like right here, checksum mismatch. If you decode something and the checksum doesn't match, then it throws an error. So that's it. Okay, any comments or questions about this stuff? So this is all quite low level, but it'll be a lot more relevant when we actually see how addresses and private keys work, because it uses this stuff. So then we'll understand all those parts.
Just a small comment that in the previous video, we talked about hash functions. And just that this is one of the utilities of hash functions, like validate stuff.
Yep.
Using a hash, you can validate that the user actually typed what he wanted to type, which is actually pretty cool.
Yep, excellent point. In fact, since you say that, let's just look at that real quickly just so that people understand what you're talking about. So what you're saying is basically here inside this code, this is what it looks like to decode. We'll look at it sort of two ways, encoding and decoding. So what it means to use the hash function is we actually compute somewhere in here, checksig, we encode the buffer, check buff. Okay, so there's a checksum function, which is actually just double SHA-256. So what it does is it takes the input and it creates a buffer that's 4 bytes longer than that, finds the hash, and the hash has the property that if you change any byte of the input, the hash is completely different. And it then adds the checksum to the start of the buffer, which is what's going on here. It's adding it directly to the start. And yeah, so the copies that went in there, yes, and the checksum. Okay, so it actually adds the checksum to the end, if I'm reading this correctly. So the hash actually goes to the end of that value, and then encodes it with base 58. So then when you decode it, let's see if I understood it correctly. So you get so the checksum, it says -4 because again, it's getting it at the end. So the checksum is actually at the end. And it just has a property that if any value at all of the input is different, the checksum is completely different, which means it can easily check whether it's the same, and then it throws an error if they're not the same. So yes, and we'll see if there are other reasons to reuse this, but if we're lucky, we'll avoid ever having the user have to type in any of this stuff anyway, and it'll be irrelevant as far as the user experience is concerned. Okay, any other comments or questions?
Well, you mentioned addresses, and I was wondering maybe it's a good opportunity to explain a little bit what is an address and what is it used for, like really summarize.
Sure, good point. So an address is basically, so we'll see this because we'll go over it in detail, but in summary, an address is the hash of a public key. And basically when you receive money in Bitcoin, you have to have an address. And in order to have an address, you actually have a private key somewhere that gives you access to the money. You never share the private key with anybody, but you do share the address. The address is something that anybody can see and they can send money to it. And so that's why it matters. Like if you give somebody an address, they better type it in correctly or you're not going to get the money. So that's why all these things ultimately matter, is that it's about making sure that the money goes where you expect it to go so that you can actually spend it.
Great, thanks.
Okay, all right, then I guess that's enough for today. And then it'll some of this stuff will be filled in as we see private keys, public keys and addresses and everything else inside BSV.